Alright, so in this example problem we have a 250-gram ball that is thrown horizontally at a wall with an initial velocity of 4 meters per second. The ball is in contact with the wall for 2.5 times 10 to the minus 3 seconds, so 2.5 milliseconds, before bouncing back in the opposite direction. The final velocity is 2 meters per second. What is the impulse of the ball on the wall, and what is the magnitude of the force the wall exerts on the ball? Alright, so our first goal is to find the impulse. An impulse either equals force times the change in time or mass times the change in velocity. And because we're given the velocities in the problem and the mass, but we don't yet have the force, we are going to want to use the relationship that I have written here, where impulse is equal to the change in momentum, where the change in momentum is mass times the change in velocity. Now we do have to be careful here because momentum is a vector. Now it matters whether or not the velocity, since mass is not a vector, now it matters what the velocity directions are. And right now, since we're doing everything along the x-axis, since the ball goes one way, hits the wall, and then comes back, we indicate that change in direction by putting a minus sign on one of the velocities. Now because I don't indicate which one is negative, you can either make the initial or the final negative. I chose, as you can see over here, to make the final velocity negative. But if you made the initial velocity negative and left the final velocity positive, that's fine. You'll just end up with the opposite sign answer as I have. Alright, so we've written our formula down here. Now the mass, we have to remember to convert the mass from grams into kilograms by dividing by 1,000. So we plug in our mass, and that is going to give us then times the quantity negative 2 meters per second minus 4 meters per second. And that gives us an impulse of negative 1.5 kilogram meters per second. In part B, we're asked what the magnitude of the force of the wall is. Now that we know what the impulse is, we can use the other half of the impulse momentum theorem, the fact that impulse equals force times the change in time. We can plug in our impulse, and we can plug in the time, so we can take the impulse divided by the time, and we get a force of 600 newtons. And I've dropped the minus sign because I asked what the magnitude is, not what the magnitude and direction of the force is. So magnitude is just size, so I don't need that minus sign. So we get a force of 600 newtons.